This momentum, impulse, and collision video will specifically be on the collisions. We're going to talk about perfectly inelastic and inelastic and elastic collision videos. Collisions. The first type that we want to talk about is perfectly inelastic. But right here what you can see is like a fish eats another fish, now they're both moving. A football player tackles another football player in opposite directions, they're both moving together. So they are stuck after the collision. Let's look at that one more specifically. This type of a collision is known as a perfectly inelastic collision. And a perfectly inelastic collision, for your definition here, is a collision in which two objects stick together after colliding. A collision in which two objects stick together after colliding. Okay, so you guys are pretty smart. What does that mean about the after effects of this? So you got M1V1I plus M2V2I, so like the silver football player, the red football player, M1, M2, they collide. What's your tail end of this? What's the after? What's the equal to portion of the equation going to read? Now they're going to have the combined mass, so like the mass of M1 plus M2, that quantity, times a final velocity, right? It's not V1F and V2F because they are now stuck together, so they are sharing and moving at that same common final velocity. So the original equation here, if you're talking about a perfectly inelastic collision, is M1V1I plus M2V2I equals VF times the quantity of M1 plus M2. Makes sense? The silver football player plus the red football player collide together to share a final velocity and a common additional mass that is put together. Okay, so here's your problem. It says an 1850 kilogram luxury sedan stopped at a traffic light is struck from the rear by a compact car with a mass of 975 kilograms. The two cars become entangled as a result of the collision. If the compact car was moving at a velocity of 22.0 meters per second to the north before the collision, what is the velocity of the entangled mass after the collision? So what do we know going into this, guys? Just read it right along here. So the first thing that you come across is an initial mass of 1850 kilograms. It says that it stopped, so V1I is 0 meters per second. Second mass of the compact car here, 975 kilograms. And the two cars come entangled as a result of this collision. The compact car was initially moving, so V2I is 22.0 meters per second. What is the combined velocity after they collide with each other? So VF is your unknown. So our original equation is M1V1I plus M2V2I equals VF times the quantity of M1 plus M2. Makes sense? The two vehicles are together, so they're going to share a combined mass and move at one final velocity. So we need to rearrange this so it just says VF equals. So M1V1I plus M2V2I is being divided by the quantity of M1 plus M2. Therefore, final velocity is now isolated. M1 is 1850 times 0 plus 975, oops, sorry, 22.0, and all of that is being divided by 1850 plus 975. Please take a second and put that in your calculators right now. Please take a second and put that quantity in your calculators. Obviously, you can just estimate this beginning portion because it's going to be equal to 0. So 975 times 22 equals, divided by, start your parentheses, 1850 plus 975, end your parentheses, enter. What's your calculator read? Please jot down your calculated answer. You should see 7.5929. Looking over at your givens, you have 3, 0, 3, and 3 sig figs. So 3 sig figs, the 2 is not going to round the 9 up, therefore 7.59 meters per second is the final velocity of the entangled mass of the two cars. Okay, kinetic energy is not conserved in inelastic collisions. So not perfectly inelastic now, guys. There is a difference. Perfectly inelastic, they stick together after colliding. Inelastic collision. Your definition here is colliding objects bounce and move separately after colliding, but the total KE decreases because sound was converted into heat, light, and sound, right? You can hear that collision. The cars feel kind of hot. There's that rubber from the tires on the road now, stuff like that. So once again, your definition for inelastic collision is colliding objects bounce and move separately after colliding. Okay, some energy is converted into sound energy, and internal energy as the objects deform and stick together. The decrease in total KE during the inelastic collision can be calculated by using the formula for kinetic energy. It's the formula for kinetic energy. You guys should recall this. Even if you didn't have physics last year, this goes back to like your initial science course, physical science course, science explorations course, fundamental science, whatever you called it your freshman year. So that equation should be KE equals, but you're going to be more specific and say KEI equals 1/2 mvi squared and KEF equals 1/2 mvf squared. Okay, so you're going to see a difference in these here. So let's try out this problem. This problem says two clay balls collide head-on in a perfectly inelastic collision. The first ball has a mass of 0.500 kilograms and an initial velocity of 4.00 meters per second to the right. The second ball has a mass of 0.250 kilograms and an initial velocity of 3.00 meters per second to the left. Calculate the decrease in kinetic energy during the collision. So going into this, we know that M1, 0.500 kilograms, whereas M2 is 0.250 kilograms. Your first initial velocity is 4.00 meters per second. And your second initial velocity is negative 3.00 meters per second because they're moving in opposite directions. You want to solve for delta KE. Kinetic energy is measured in joules. So you want to start off with perfectly inelastic collision. M1V1I plus M2V2I equals VF times the quantity of M1 plus M2. Makes sense? Because what does it mean if it's perfectly inelastic, guys? What type of collision are you experiencing? What's the after effect if it's perfectly inelastic? That means that the objects stick together and move as one final velocity. So there, that would be the quantity of M1, M2, and VF on the right-hand side of the equal sign. Okay, so from that we can solve for our VF. So we want to rearrange this to say M1 V1I plus M2 V2I all over the quantity of M1 plus M2 equals VF. Therefore, we have 0.500 times 4.00 plus 0.250 times negative 3.00. All of that is being divided by 0.500 plus 0.250. Put that in your calculators, please. Don't forget those signs there. Pretty darn important. Your calculator answer should be 1.67 meters per second, whereas we do want 3 sig figs if you assess your givens here. It's not a final answer, but let's start because it's pretty important. So now we want to know that our final equation is delta KE equals KEF minus KEI, right? KEF is going to be 1/2 mVF squared, whereas KEI is going to be 1/2 M1V1I squared plus 1/2 M2V2I squared. Makes sense? So this is one entity. That's going to be one answer right there. From this you have a breakdown here, right? Because you don't know what the final velocity is. Yeah, you do. You know that the final velocity is going to be 1.67. So this is 1/2. M total here is 0.500 plus 0.250 times 1.67 squared. Going to get that, and you're going to subtract it from all of the beginning line up here. So I'm just going to draw an arrow right here. When you plug that in, you should get 4. And when you plug this guy in, you should get 1.125. Guys, I'm not subbing it out here because of the board space, okay? I'm not trying to not show you how to do it. Please do take a second and put those numbers in there and see if you get 4 and 1.125 respectively as well. Okay, so that would mean that you should ultimately have then 1.05 for a KEF minus 5.12 for a KEI. Okay, so with that in mind, taking the difference between those two values gives you 4.07. Remember, we're subtracting now, so you want the least to the right of the decimal, and the least to the right on those two numbers is 2, so your final has to have 2. Now we're going to assess the ultimate final answer. The ultimate final answer should have 3 grand total sig figs, which 4.07 does. So therefore, delta KE is 4.07 joules. That is your final answer, 4.07 joules. Negative 4.07 joules, because it was minus 5.12. Okay, moving right along. Kinetic energy is conserved in elastic. So we've talked about perfectly inelastic, inelastic, and now elastic collisions. An elastic collision is a collision in which the total momentum and KE are conserved. So this is where total momentum and kinetic energy are conserved in a collision. Total momentum is constant throughout the collision. If the collision is perfectly elastic, the value of the total kinetic energy after the collision is equal to the value before the collision. That should make sense, right? Okay, so here comes our final problem right here. We have an initial mass of 0.015 kilograms, a second mass of 0.030 kilograms, an initial first velocity of 0.0225 meters per second, and a second initial velocity of negative 0.180 meters per second. Your first final velocity is a negative 0.315 because they changed directions due to the collision. So I want you to solve for the second final velocity in meters per second. So this equation is going to become m1v1i plus m2v2i equals m1v1f plus m2v2f. So it's kind of like those billiard balls all the way back at the first video that we watched here. Rearranging this, we should get negative m1v1f plus m1v1i plus m2v2i all over m2 equals v2f. Okay, so this first entity here, you should have a negative 0.1575. Wow, Miss Arter. Negative 0.1575 plus 0.1125 plus a negative 0.180. Putting that into your calculator, you should get a final answer of 0.09. That's only 1 sig fig, but you need a grand total of 2 sig figs in your final answer. So 9.0 times 10 to the negative second, what guys? Meters per second. Very, very good. Meters per second is what the second final velocity is. Please make sure that you do take a second and you do plug in what M1V1F is, what M1V1I and M2V2I are, so you can see if you get those answers as well for your final answer of 9.0 times 10 to the negative second meters per second. Here is an awesome table to sum this all up. Please make sure you understand this table. And at this time, please do your collisions worksheets.